The table above gives selected function values and limit values for the functions f and g. Use these values to evaluate this limit, the limit as x approaches 3 of 2f of x plus g of x. Well, the nice thing about limits is if you're taking the limit of like a polynomial or something like that, and that's what this is trying to represent. You're trying to show that you're taking the limit of something like 2x squared plus 8x or whatever. I'm just literally making things up. Not that that matters. What you could do is you can almost, you can almost distribute that limit to everything. So you can make this 2 times the limit as x approaches 3 of f of x plus the limit as x approaches 3 of g of x. And now that we have that, we're kind of like, oh, well, none of this matters. And it doesn't. You're absolutely right. None of that does matter. What we do care about is the fact that the limit as x approaches 3 of f of x is 5. So 2 times 5, drop down the plus, and the limit as x approaches 3 of g of x is 4. So this becomes 10 plus 4, and 10 plus 4 is 14. So kind of a tricky problem, kind of a weird problem, but we did it. Given the function f shown below, evaluate the limit as x approaches 1 from the left of f of x. Now what we have is a piecewise function. All right, we have some type of quadratic which turns into some type of linear function which turns into some type of cosine, and we don't know what anything looks like. But what we do know is that at this one moment, at 1, okay, at 1, and in fact, me drawing that straight line right there, this is 1 right here. But at 1, we have a dot, right? And from the left of it, we have a quadratic that turns into the dot. Now, what we care about is what's going on from the left, which means we care about what happens at that moment right there. So we are going to focus on that equation. We're going to plug in 1, right? So we're going to do 1 squared plus 3 times 1 minus 5. And what this does is this gives us the limit as x approaches 1 from the left. 1 plus 3 minus 5 is going to be negative 1. All right, so since this is coming from the left, we are focused on the left-sided part of this piecewise function, which is that first equation right there. We plug in 1 because the limit is basically at 1, so it's like, 0.9999999, and then we get negative 1, which is going to be our limit. That's it. Evaluate the limit as x approaches negative 6 from the right side. Now what I have is basically some type of absolute value, rational looking thing. I don't know, but usually when I deal with like left-handed and right-handed limits, I'm expecting something like this to happen, right? Where I have to worry about one side. And if this would be 6, then I'd have to worry about there. But that only happens if there's a known disruption, a known discontinuity. My discontinuity would happen at 1. 1 minus 1 is 0. So any discontinuity doesn't happen at negative 6. This is just going to be continuous at negative 6. So it doesn't matter if it's coming from the left. It doesn't matter if it's coming from the right. I just plug in negative 6 and do a little bit of math. So 3 times negative 6 plus 4 all over the absolute value of negative 6 minus 1, close the absolute value. In the numerator, we have negative 18 plus 4. In the denominator, we have the absolute value of negative 7. That simplifies out to negative 14 over positive 7, which gives me negative 2. So again, the trick of this is you would look at that from the right thing and be like, oh, I wonder what that means. Well, in this case, since this is a continuous function, absolutely nothing. It means nothing. You just substitute in negative 6, do the problem, everything's fine. The graph of g of x is shown below. Evaluate the limit as x approaches 0 of 3 cosine x g of x squared. So this is strange. So this is like a weird extra problem that I'm just giving you more than necessary. Okay? No big deal. What I do know is that the limit as x approaches 0 of 3 cos x is going to be 3 cos 0. Now, g of x squared means I go to this graph and notice that at 0, my limit appears to be 4. So the limit as x approaches 0 of g of x is 4. If I were to take that and square it, I would get 16. So I'm going to multiply that guy to 16. Cosine 0 is 1. So I get 3 times 1 times 16. Ooh, 316. Which is going to be 50, nope, 48. Ooh, that was a close one. That was a close one. Yeah, but that's what I get. Kind of a strange problem. Made you think outside the box a little bit.